Hello, today we're going to do a learning video on how to draw Lewis structures for covalent molecules. There are a couple of steps to drawing a covalent molecule. The first step is you're going to be given the formula. You need to find the sum of the number of valence electrons in that formula. For example, if you have CH4, carbon has 4 valence electrons and there's 1 carbon. Hydrogen has 1 valence electrons and there are 4 hydrogens. The sum is 4 for carbon, 4 times 1 for hydrogen, which gives you a sum of 8. The second step is to determine who your central atom is. This is typically the atom with the most empty spaces in the Lewis structure. Again, with the same example, CH4, carbon has 4 empty spaces. It needs 4 more electrons to have a full valence. Hydrogen only has 1 empty space. It needs 1 more electron. Remember, hydrogen only needs 2 valence electrons for stability. So carbon is your central atom. There are some exceptions to this rule, which you'll take a look at later on. Your third step is to write the symbol for your central atom and then put the bond with the other atoms around your central atom. We're going to use a line for that bond. That is the sharing of those 2 electrons. So you draw your structure, central atom, and then bond your other things around your central atom. Again, remembering that in a covalent bond, the 2 electrons are being shared, and that line represents those 2 electrons. Your next step, count the number of electrons around each atom in your drawing. So when I take a look at our example, CH4, I'm going to count my total number of electrons being around that structure. So I've got 2, 4, 6, and 8. There are 8 electrons around carbon and 2 around hydrogen. Going to continue that. If the number of electrons is equal to the sum from our first step, our picture is complete. It works out. So our example, CH4, our sum in our first step was 8 electrons, and we have 8 electrons in our drawing, 2, 4, 6, 8. So our picture is complete. Sometimes your picture doesn't work out right away. If that happens, this is what you need to remember. If you have 2 more electrons in your drawing than your original sum, you need to make a double bond on your central atom, and then remember to reoctet all of your atoms in your drawing. If you have 4 more electrons in your drawing than your original sum, make 1 bond on your central atom, a triple bond. So change one of your bonds to a triple bond on your central atom, or second option is to take 2 bonds on your central atoms and make those 2 double bonds. Now, when you do that, remember to make sure you reoctet again. So here's another example. Our first step was to sum. We've got the formula, carbon dioxide, CO2. So when we sum, carbon again has 4 valence electrons. Oxygen has 6 valence electrons, and there are 2 oxygens. So our sum is a 16. That's the number we're looking for to have our picture be complete. We look at next who our central atom is. Who has the most empty spaces? Carbon has 4 empty spaces, and oxygen has 2 empty spaces. Carbon is our central atom. Then we draw. We put carbon in the middle and bond our 2 oxygens onto that central atom. Remember, we show that bond. It's a pair of electrons being shared with a line. Octet everybody. Make sure everybody has 8 valence electrons around it except for hydrogen. And we don't have hydrogen in this example, so we can keep going. And then we count how many electrons are in our drawing. So when we count, we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So we've got 20 electrons in our drawing, but notice our sum. So our sum is 4 electrons too many. When we're 4 electrons too many, our first option is, or one of our options, excuse me, is to make 2 bonds double bonds. So we have right now 4 electrons being shared between this oxygen and carbon, and 4 electrons being shared between this carbon, or the carbon, and this oxygen. We have to reoctet to make sure everybody has 8 valence electrons around it, and that's why you see the difference on the number of electrons on the oxygens that aren't in a bond. So now when we check it, we've got 2, 4, 6, 8, 10, 12, 14, 16. Our other option is to make one bond on our central atom a triple bond. So in a triple bond, there are 3 electrons being shared between the carbon and the oxygen. And it looks like I forgot something. I apologize for that. I forgot to octet right here. So there should be a pair of electrons right here, which would be 2, 4, 6, 8, 10, 12, 14, and 16. And obviously these got a little bit off-centered too, so we should fix that. But again, a pair of electrons are right here, and we've got a total of 16. Now, another example would be drawing a polyatomic ion. The nitrate polyatomic ion, NO3 with a -1 charge. Remember, -1 means that for that structure to happen, it gained an electron. So when we do the sum, we have to take a look at those charges. A negative charge means that you're going to add that number of electrons to your sum. If it was a positive charge like ammonium, NH4 with a +1 charge, we would subtract those electrons from that sum. It lost an extra electron to make that structure happen. So in NO3 -1, there are 5 valence electrons in nitrogen, 6 valence electrons in oxygen, but there are 3 of those, and then the -1 charge means it gained an electron. So we add 1 to our sum, and we're looking for 24 valence 24 for our total sum for our picture to be correct. Our central atom. Nitrogen has 3 empty spaces. Oxygen has 2 empty spaces, so nitrogen is our central atom. We do the drawing, and we octet rule everybody. And so we make sure that there are 8 valence electrons around each atom, unless of course it was hydrogen, which we don't have. Hydrogen, remember, only has 2 electrons and then it's complete. So we did that. Remember, the lines show the shared a pair of electrons, and so now if we count those up, we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and 26. Our sum was 24, so we are 2 over. You're only 2 over, so our option is to change one bond on our central atom to a double bond and then reoctet. So we look at our new picture. Well, the double bond was put right there, which look at the oxygen and that reoctet. So if this oxygen, 2, 4, 6, 8. So that oxygen is good. Nitrogen, notice that there's not that pair of electrons up there anymore because we've got 2, 4, 6, and 8. And so when we do our total, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oops, did I goof that up? Let me try again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. And that was our original sum. Now, because it's a polyatomic ion, we need to tell somebody that that electron was gained from something else, typically a metal that needs to lose an electron. So we put a polyatomic in brackets, and then we put the charge on the outside of the brackets.